Hi all, this is Christoph from Energy and Climate Systems 3, and in this video I'm going to show you how to use Hive for conducting initial solar irradiation analyses. For this exercise, let us open this file that you can download from Moodle, the Hive Solar Unobstructed G8, and you can do that by just drag and dropping that onto the Grasshopper canvas, like so. And what you will see here is you have these different areas that we've grouped for you, and let's for now only look at this part, the sunpath and unobstructed surface insulation group. You will find three components in this group. One on the left hand side is just an EPW reader, so it opens and reads the contents of a weather file. And outputs all the information of it. Then here you will find a solar irradiation analysis tool that does not consider obstruction, so that is important to know. However, this is super fast, so if you know that your surface area that you're looking at is not obstructed, or if you're just interested in general tendencies of or generally on the impact of, let's say, tilt and azimuth of your panel on irradiation, then this is a good tool to use. And on the bottom, you will find a sunpath diagram that is doing similar things than the ladybug sunpath diagram that we have put here for you for comparison, or if you want to use some of the graphics here instead. Okay, and the surface irradiation component is connected to a quick graph component from Grasshopper to show you the irradiation. Now this one doesn't show a unit, so if you want to do a more thorough analysis, it would be good if you can copy paste this data by right clicking on this panel, copy data only, and then you can go to Excel and just copy paste this data, and then you have the values as numeric entries in watts per square meter in this case. Alright, so going back to Grasshopper, what you can use this tool for now is you can see that this component is connected to two parameters, tilt and azimuth, which you will find here on the left hand side. And let's just move this graph over here. And now if you start changing these two parameters, tilt and azimuth, you know, which basically, or we're just showing the surface orientation of a imaginary surface, then yeah, you can see how that impacts annual irradiation. Oh, I forgot to mention that this graph shows annual hourly surface irradiation values. And you can see that this is super fast, so that the calculations that are happening are not too complex. But this can already very quickly give you an idea of how much irradiation you would get out of a certain surface, let's say. And one thing to note, the scale is always changing automatically in this component, so maybe it is good if you connect to this graph the global horizontal irradiation from the weather file, because that one always stays the same for each weather file or location. You can do this by left clicking here and holding the shift key on your keyboard, so you see that there's a little plus appearing on your mouse cursor, and then just drag and dropping it into the input of this graph component. And by doing so, you will always have the global horizontal irradiation, which, as I said, stays constant no matter the orientation of the surface panel. And then you can compare how your surface performs relatively to the weather location. And yeah, when you tilt it to, let's say, 90 degrees, which would be a normal wall, straight wall, and then you start rotating this to north. So these values are, by the way, in degrees, and 0 would be north, so would be 360, by the way, and 180 would be south. Yeah, you can observe how your surface then performs in terms of solar irradiation. Alright, so that's this part. Let's move this back here. So if you want to, I actually forgot how to mention, if you want to change your weather file, then you can do it by simply changing the path to your file in this text box. And let's say you have, well, I don't know, would basically just copy paste any file that you have into here, and it needs to be an EPW, and it should have loaded. Well, you didn't see how it changes, but it's Control Z. Yeah, so now that's for San Francisco, and that's for Chicago, and that's how you change the weather file. Moving over to the sunpath component, which is this guy over here. For that, let us also have a look at the Rhino modeling viewport over here to the left. You will find that we have internalized some geometry already, and these geometries you can replace with your case study that you're working on. Basically, just this mesh component for the context or all obstacles around your building, and this one is a part of Zurich somewhere. For visualizations, it's always actually nice to bake this thing. Bake. Yeah, and then it looks a little bit better, because otherwise the render is a bit weird. So let's have it baked. And let's say you want to replace this input data with your own geometry, then you need to keep in mind that it has to be a mesh. So let's say that's your city. So I mean, this is actually Grasshopper basics, but let's just go over it very quickly. You can put that into depending on what kind of geometry you have, just connect it here, and then yeah, your geometry is inserted in this file. But let's stick to the Zurich example for now, because it has some nice geometries. And as I said, it's nicer when we bake it or when we have the real geometry here in the Rhino viewport, just for visualization purposes. And now what you can already see here is a sky dome and a sunpath, very similar to what Ladybug does in the exercise that you did last week or last weeks. This component here would be very interesting. That's the analysis point, for which we construct a sky dome above it. And this guy you can actually move. So if you click on this point, which can be really any point, and you move around with this point, then you can see different things. Well, one thing actually, which is if we go on the top view, side view top, we can see actually how for this point the view factors to the sky is shown here in gray. And we can increase the resolution of this analysis by changing the recursion level parameter to something higher, let's say 3 or 4, depending on how fast your computer is. You can keep this high or low. And then, yeah, you can see how shaded your site is. And in this context, it's always nice to keep the sunpath also activated, which actually is always on by default in this example. But I'll show you in a second how to deactivate it. Because now, if you have the sunpath overlaid to the sky view factor sky dome, yeah, you can very quickly see which parts of the sunpath are covered. And especially here, if you're interested in photovoltaic electricity generation, you might want to make sure that those bits of the sky where the sun traverses are unobstructed. And then we would find a spot somewhere where we have no shading for our PV panel or our solar gains through our windows. All right. Yes, you can toggle off or turn off the sky view analysis to save computing time if you don't need it. And also you can turn off this sunpath if that should annoy you. And you can find all the parameters that you can set to this sky dome component here, and turning off the sunpath would be here. So you can either connect a Boolean toggle, so double click on the grasshopper canvas and type in Boolean toggle and have this on false, and then connect that to sunpath, and it's gone. Or yeah, there are different ways. I mean, you can also right click here, set Boolean, false true. Whatever is best for you. You will also find a solar vector toggle, which will draw, as the name suggests, a solar vector for a certain hour, and this hour of the year you can enter here, and that would be a number from 1 to 8,760, so the number of hours per year. And if you want to, you can connect a number slider to that. It has to be an integer, so right click on this slider component and hit integers, and then also set the values from min, actually I think it's from 0 to 8596. No, wait, 8569 exactly. Okay, and then we can connect this to hour of the year. Now we have to set this to true. It's already. Yeah, and then if you now change this, yeah, let's reduce the recursion level, or actually let's turn it off entirely. We don't need it right now. Yeah, now you can check the solar vector for each respective hour of the year. Yeah, it's a little bit difficult to navigate with this slider, but yeah, you get the idea. Okay, so much for the I think that's it, yes. So much for the sunpath and unobstructed surface installation analysis. And this kind of analysis is nice if you want to make very fast and very early considerations to your design. But as I said, it is important to keep in mind that this graph does not consider obstruction of the surroundings into this irradiation analysis. The sky view factor does consider this obstruction, as you can obviously see here, but this component does not for now. Yeah, just play around with it a little bit and have a look.